Hi, here we go with a quick video on basic differentiation. We're in chapter 2.2, basic differentiation rules. All right, so we have one rule. It's called the constant rule. And if I bring this into focus a little bit more here, there we go. Constant rule is the derivative with respect to x of any constant c will equal 0. And why that is I'll show you in a bit when we do the power rule, but essentially if you have some value of a constant, say it's 5, and there is no variable, and therefore there is an exponent of 0, and I'll show you a quick example once I go through the power rule as to why it becomes zeroed out. All right, so the next one is the power rule. And the power rule basically states that the derivative with respect to x of any x to the nth power will yield an n times x and then n minus 1. So in writing, or what it means is you bring down the power of n and multiply it to the coefficient. Then reduce the power by 1. So, again, if I were to look at this constant rule and I saw that I had some value, say, of 5, well, this is really x to the 0th power, right? Because x to the 0th power is 1. Well, if I bring down this 0 here and I go 0 times 5x, it doesn't matter if I reduce the power. As soon as I introduce that 0, being multiplied, that is equal to 0. So that's why any constant will go to 0. All right, so let's look at some examples of the differentiation power rule a little bit more in depth. So here's example number 1. Put this over here, where we see example number 1, f of x is equal to x cubed. I'll try to color code this for you so you can see where things went. But what you notice is x cubed. Again, we bring the power down. So in essence, I'm taking this 3 and I'm going to bring it down front. So there's the 3, shows up there. And then I have to reduce the initial 3 by 1, so 3 minus 1. And we end up with f prime of x is equal to 3x squared. Okay? Let's look at another example here that shows us we get f of x equals 2 divided by x cubed now. So we have an x value in the denominator. So the first thing we should do is rewrite with a negative exponent. So everything is in the numerator. So all the values are in the numerator. So what we get is f of x is now equal to 2x to the negative 3 power. And if you don't recall your exponential rules, go back and look those up because it's pretty vital from here on out that we're going to be using those quite a bit. Again, we take the power that is currently existing, we bring it down in front, so there's our negative 3, times the 2. We take the existing power of negative 3, subtract 1, and so when we multiply these two together, we get negative 6x to the negative 4th. Now, I want you to be able to, you should, in most cases, write your answer in positive exponential form. So the negative 6 stays in the numerator, and again, if you don't recall your rules from powers, once you have a negative as an exponent, it actually moves it down to the denominator to become positive. Same way as if I have a positive in the denominator and I move it up, it becomes a negative. So your final answer here of f prime of x is negative 6 divided by x to the 4th power. Okay, final example. This involves some roots. Gets a little tricky, so you might have to recall some root rules as well. So we have f of x is equal to the cube root of x squared. Rewrite in exponential form. Recall that the nth root of any x to some nth power is equal to x of nth power divided by its root. Okay? So here's our example. So if f of x is equal to, if it was 3 root x squared, I'm going to rewrite it as x to the power of 2 over 3. Then I'm going to bring this down. So first step is to, again, we take this power down. We see that it's 2/3. We get x to the 2/3 minus 1. 2/3 minus 1 is negative 1/3. So we're with 2/3 x to the negative 1/3 power. And now I want to rewrite that with positive exponent. So this x and everything with it will go to the denominator. So we get 2 over 3 times x to the 1/3. And now I'm going to rewrite that in exponential, or back into root. And so we get 2 divided by 3 times the cube root of x. Because that little 1 that was right there is there. We just don't see it. We don't have to write it in. Okay? I urge you to go back through that process, re-look through this example and the others, and make sure you understand your properties of not only exponentials, but also of roots in exponential form. All right? Hope that helped. I'll do another video where it may be a little bit more complicated. Work on those. All right? Thanks. Have a great day. Talk to you soon.